Okay, so the recording has also been started already. So welcome folks to BayOne's Bootcamp series on technical topics. Today's session is going to focus on front-end engineering and front-end technologies. Um, Let me quickly share with you our presentation for today. All right, so we are BayOne. We provide IT services and consulting, as most of you are aware. And we welcome you to this bootcamp, BayOne Tech 101. We had an intro session a couple of days ago, so we have covered a lot of these things, including background about myself. So I'll not go over that today. But it's my pleasure, it's our pleasure to host these series. And thank you again for being a loyal attendee. So what are these BayOne 01 Tech Bootcamps? These boot camps will be covering a lot of technical topics, and it will be fairly generic, although geared primarily towards engineering people, typically software engineers. Attendance is not restricted to just the software developers. So if you are an aspiring developer, or if you are a program project manager, or if you are into quality engineering, or even if you are a high school student now looking towards creating a career in the STEM field, you are more than welcome to join us. A quick reminder, folks, please do mute your lines. If you have any question, you can unmute yourself and ask the question. So typically in these boot camps, we will be covering a varied range of topics, starting from programming, of course, including front-end, back-end, full-stack programming, and also topics in data analytics, data science, data engineering, AI, machine learning, deep learning, including DevOps, CI/CD, and product and program management. Now, this is a huge wish list, so we don't know how long it'll take us to cover all these topics, but our recommendation is join us. These are just 2 hours, every session at the max, and done just twice a week. You will definitely learn a lot. You'll get a lot of guidance in terms of what kind of online resources to pursue to get more knowledge on the topic that's being covered on any given day. And as I mentioned, twice a week, Tuesdays and Thursdays, ideally about 90 minutes, but we have a 30-minute buffer, and historically we have seen that it usually goes up to 6 o'clock. So do plan your time accordingly. And as today, we will mostly have, in addition to myself, at least one additional industry expert or SME who would be talking about the topic being covered on that given day. So what are we covering today? Front-end bootcamp, talking about front-end engineering and technology, user interface, and to some extent, user experience as well. So what is UI? What is UX? Where did all of this start? We have no one better than a person who works right at the forefront of all of this at LinkedIn, Sarbottam Bandyopadhyay. Sarbottam is a senior software engineer at LinkedIn, and he'll be walking us through the history of UI UX. Why is it important? Where is it today? What kind of technologies are being used? And he has a very ambitious agenda for all of us today. And in the event that we are not able to cover everything, we will extend this session into our next boot camp as well. Let's see how it goes. Folks, you can unmute yourself briefly to give a warm welcome to Sarbottam. Sarbottam, welcome.
Thank you. Thanks, everyone. Thank you for joining. And thanks, Shubha, for this warm introduction. Before we begin with the presentation, I'd like to speak a little bit about the word Shubha said, like the UI. And when, before I talk anymore, am I audible? Can you hear me all right? And is it loud and clear? Is my pace is fine? Because I'll probably schedule according to that. Okay, I see a thumbs up from Shubha, so it looks fine. So this word UI, I kind of see it as you and I. The you is the user, and I am the developer who is creating these user interfaces. So it's kind of a dialogue between the user and myself. And so we should make this as pleasant and as efficient and as possible. So without any further ado, like we probably have a lot of things to cover. Let me go ahead and share my screen. Suva, is there anything else you would like to say, or we can get started with the presentation?
I think we can get started with the presentation. And I know all of us are now working from home, so we have dialed in using our home Wi-Fi bandwidth. So there might be some challenges in terms of audio and video. So first of all, my request is everyone please mute your lines unless you have a question to ask, number one. And number two, I think Sarbotam, both yourself and myself, we can also turn off our video lines. That way,
Yeah,
the sharing part and the audio will be clear to all the attendees.
sounds great. I am turning off my video and I'll have my microphone on and we'll take it from there on. So let me start my presentation and let me share my screen first and then we'll start the presentation. Can anyone confirm, like if you can see my screen, there should be a in logo on my screen.
Yes, we can see it. You're all
Perfect. Perfect. So thank you everyone once again for joining. I understand this is really warm weather outside and you probably cannot go for doing anything, any physical activity. So let's use our time with the best available resources and talk about technical things. And thank you Suva and BayOne for setting up this platform and this place so that we can share our knowledges and also learn from others. So today I will be talking about front-end engineering, and I'll be talking about this whole front-end engineering in a very, very fast pace, which will be probably in supersonic speed. And the reason behind this speed, because we'll be covering almost 30 years of history. So we have to cover the highlights. We cannot cover each and everything, but even then we have to be a little bit faster. So Subha already has introduced myself. And once again, my name is Sarbotam Bandyopadhyay. I am a front-end engineer at LinkedIn. I have been doing web applications since 2005, the time when jQuery was not available. And I had to write code for 3 different kind of browser, Netscape, IE, and Firefox just came into the picture. So I've been doing it for quite some time. And today's agenda, today we'll be talking about front-end concepts. We will take a peek at Node.js. We'll also touch upon responsive web design, talk about few libraries and frameworks, what we used in front-end development, and to end with an example interview questions from a real-world use case. So whether it is twitter.com, facebook.com, linkedin.com, Craigslist, or Wikipedia, whatever you see today, these sites are all powered by 3 crucial technology, which is HTML, CSS, and JavaScript. Of course, there are servers, which is rendering these pages, which is responding to the user's request. There are load balancers who are managing this request appropriately. There are CDNs, which are taking care of delivery or proper timely delivery of these static resources. But still, the core technology, which is rendering this view in your browser, is HTML, CSS, and JavaScript. So these are the 3 pillars of any front-end engineering. So what is the purpose of HTML, CSS, and JavaScript? HTML adds the structure to the document. We call it document. We'll come to that pretty soon. Why do we call it as a document? So HTML adds the structure to the document. CSS makes it look better with the shiny things, making the font look bold, the color of the font, the layouts, and so on and so forth. And JavaScript adds the behavior to the web application or your web page. So these are the 3 main pillars. Let's take a quick look at what a bare metal HTML could look like and a very simple CSS and JavaScript. So this is an HTML which looks like, so you probably have seen it multiple times. So it starts with a doc type. The reason it starts with a doc type because HTML itself is an XML. And for any XML structure, any XML markup languages, you have to have a DTD, which is the doc type definition, so that the parser knows what to do with the HTML tag, head tag, title tag, body, and all the other tags which are available. So an HTML document has the HTML tag as the root tag, which is the outermost tag. And it has 2 siblings. One is the head and one is the body. So head is for all meta informations. What is the title of the page, how you are linking the style sheets, what is the description of the pages, and in the world of social media, how that HTML, how a card would look like, what would be the fab icon out there, what is the card image that if you're sharing this link in Facebook or LinkedIn or Twitter, all those information goes into that head within the head tag. And the body, that's where your content starts. Like what are the content you're putting out there? What is your header? What is your description? What are the images? Is there a carousel? Is there an accordion? And so on and so forth. So one thing, if you are already working with front end, you might notice that in the script tag, I have a keyword called differ, which is a very new thing. Why did we add that keyword differ? So what happens when you make a request, like for example, to the linkedin.com or facebook.com or twitter.com, the request goes to the server starts sending you the packets, which will be actually HTML, and the browser start intercepting these packets and starts parsing. So the moment browser says, hey, doc type HTML, okay, I know what to do with this. This is going to be an HTML, so I will prepare a document object model from here, and the browser's parser starts parsing it. So browser has parsed the HTML, the head, title, link. Oh, you saw a link, so let me get a style sheet. So it makes a request for main.css. The styles come out. The moment browser sees a script tag, it understands that the application is making a request for a JavaScript. And JavaScript has the power to alter the DOM. Like you could do document.something, document.writeln or something like that, and you could alter the DOM. So browser is very clever. It doesn't want to do the same thing again. It doesn't want to do the repeated thing. So what it does, it stops parsing and it makes a call for the JavaScript. So the server responds with the JavaScript, browser starts parsing it the JavaScript, executes the JavaScript, and then resume your parsing of the HTML. So suppose the JavaScript was really, really long, maybe 1 MB or 2 MB. It will take a long time to get transported to the browser, and browser will spend probably even longer to parse it. And till that time, your user is not going to see anything, just blank screen, which is a very, very bad experience. So in the older days, what we used to do, we used to have this script tag at the end of the body. Like, okay, the HTML got parsed, the browser parsed the HTML and started rendering it. Then we'll have the JavaScript, because it was progressive enhancement. Whatever you have to show it to the user, you have already shown it. Now you're enhancing the experience. But with the newer evolution, we have this keyword called differ. So the browser says, okay, this is a script tag. Maybe I should stop parsing my document. But then it says, hey, there is something called differ. Okay, I don't care about this anymore. I'll get the JavaScript and I'll continue parsing my HTML and I'll render. Once my system is idle, my whole document has been parsed, then I'll get to the JavaScript. Like it's kind of a scheduled thing. So that's very important today. Now let's take a look at a very simple CSS style sheets. So style sheet is nothing but collection of rules. So you see there are two rules which I have. One is for body and one is for H1. So these rules could be associated with a tag, as I have it here with the body, or it could have been with a selector, class selector, ID selector, type selector, or any such kind of thing. And it consists of a property and a value. So background color is a property and light blue is a value. Similarly, in H1, you see color is a property with the value white, and text align, again, a property with the value as center. And the third piece of the puzzle is JavaScript, which is nothing but functions. So you write some functions, functions greet, functions hello, functions XYZ, and you invoke this function either on user interaction or on some event. Maybe the event could be when the page has loaded, like tell the user, hey, would you like to have notifications turned on? So that could be on an event. Or the user clicks on a button, then you perform some actions, so which is user driven. So in this example, I have a button in my page. When the user clicks on the button, it just shows hello world. It says alert, hello world. So if I put all these things together, this is what it comes up like. So you can see the HTML on the first panel, then I have the CSS, then I have the JavaScript. When it got rendered, as you can see, the CSS is dictating how the hello world should get rendered, whether it should be white, it should be text aligned in the center, in the middle. The body should have a color which is light blue, and the behavior is coming into the picture. When I click that button called click me, I see an alert which says hello world, and that is driven by the JavaScript which I have. And this is pretty important, this JavaScript thing. It once upon a time, it actually changed the name, and we were calling it as a DHTML or JavaScript. And guess what? We also have books written on how to make dynamic HTML. In today's world, we do not talk about it anymore because JavaScript has become mainstream and it is prevalent everywhere. So far, I have talked about HTML.
This is a great introduction, and pardon my interference here, but I just wanted to take the pulse of the audience. To many of you who have background in front-end engineering, this was very, very basic, right? But for those of you who have primarily worked on the server side, or the non-programmers on the call today, like the project program managers and maybe even folks coming from quality assurance side, some of these things might still be new. So please feel free, as Sarbotham mentioned, to ask your questions. So far, any questions, anybody? Can you go back to the previous slide, Sarbotham?
Sure.
Which is a summarization of what you have covered so far. So HTML, cascading style sheets, and JavaScript, the three components of UI, right? Any questions so far? Okay.
I see there is one question from Poonam. What is particularly important that's new with HTML5? Very, very good question. So the first thing, let me go back a few slides real quick since you asked this question. This is really important. So let me go back. So the first thing which came up with HTML5 is the doc type. If you go back to the previous era, and if you inspect the pages, you'll see a really, really long doc type. And as I already told you, like this doc type specifies how each tag should behave. And there's an important history behind it. So Microsoft originally had Internet Explorer, and then they thought that, hey, Internet Explorer could also be on Mac. And the web did not have a standard at that point in time. So then Microsoft had to develop a quirk mode only for Mac, the IE Explorer, which was developed for Mac. Otherwise, all the pages were breaking in that particular pages. So they had to come up with a new concept of different doc types. So that's the very first thing. You do not write a lengthy doc type in HTML5. The second thing, we got many facilities with HTML5. Like we got new input types. Like earlier, it would be only input type text. Now we have input type telephone, which are not only good for desktop, but also for mobile friendly. Because if you have provided input type equal to tel or number in your mobile keypad, the whole soft keyboard will not come up, which will only bring up the number keyboard. So that's very good for user experiences. And we have many more input type, not only input type tel or input type number, we have input type color. You can have a color choice out there. You can choose different colors. We also got the drag and drop API. Like now, if you have to upload a photo, you have to click the file browser button, then choose a photo and upload it. Nowadays, if you're using Google Photos or any such kind of thing, you can just do a drag and drop. So that came into the picture, which is very, very useful for user experience. We also got many other benefits, which is behind the scene, like the history API, which made the life of single page application framework developed really, really easy. Because in single page application, when you're creating the back button in your browser, it actually doesn't make a call to the end server. It manipulates the history and renders the view from the previous cache, which is had. We will talk about that when we talk about the single page application, but these are the few of the benefits which came up with HTML5. Is that okay, Poonam? Does that give you a brief overview? We can talk in detail once again when we'll go back to the main sections. Perfect. I got a response from Poonam. So if there are no questions, we will move ahead again. And Feel free to interrupt me as Subha has interrupted. This session should be more of a knowledge sharing. It's not just like I want to continue speaking, it should be interactive. So if you have any doubts, please feel free to interrupt me. So we are talking about dynamic HTML. We don't use this term anymore. The dynamic word got added just because of JavaScript, because when web was initially uh, conceived, there was no JavaScript. We'll talk about the timeline in a moment. But before that, you probably have this question in mind, like if you're like me, like, okay, I understand JavaScript, I understand HTML, I understand CSS. You talked about them, that this is a structure, this is a presentation, this is the behavior, but how the browser is painting them, how the whole thing is actually playing. So maybe this picture can give you an overview. So when the browser starts parsing the HTML, as I told earlier, it creates something called DOM, or document object model. So it's a tree. If you're a backend developer, you already are aware of what is a tree structure. So this is a tree structure. This is more of an n-array tree. Similarly, when the browser is parsing the CSS file, it creates something called CSS OM, which is a CSS object model. And then browser brings both of them together, like body to body. It matches all the selectors. So wherever you have, if you see this picture, it has a body on the DOM, it has a body on the CSS OM. It has a P below the body in the DOM, it has a P below the CSS OM out there. It brings up these two trees together and it creates what is called render tree. If you see the render tree, the body gets a font size of 16px because the body is in the DOM and the 16px font size in the CSS OM. Similarly, the P tag below the body got a font size of 16px, which is inherited from the body, and it got the font weight bold from the CSS OM, and so on and so forth. Once this render tree is created, browser starts painting this tree more like raster scan method, like top left to bottom right. That's how the whole thing gets painted. So when you develop web applications, you also have to be very careful not to alter the geometry too much, because the moment you alter the geometry of the page, like if there was a button which was 100 pixels by 200 pixels, all of a sudden, for whatever reason, user has hovered over there and you want to make that button look big, that actually triggers a reflow. So the browser have to calculate the whole geometry once again and paint it. But it does so seamlessly that we don't even realize, but it is very expensive operation. If you are building front-end applications, you have to be very, very careful about not to thrash those layout. And in this current era, when we are trying to achieve 60 frame per second animations, like any such kind of things, and if you have an animation out there, it will probably look janky if you're thrashing it too much. So you also have to be careful about it. But that's fine. I think we have covered the overview overview of front-end engineering by this time. But how this thing has evolved over the time, how did this all started? So let's take a look at the timeline, a brief history of web development. It all started in 1991 when Tim Berners-Lee announced www, the World Wide Web. The primary intent of World Wide Web was not what we do today. It was primary to share documentation between scientists in different institutes and different universities, so that they can easily share their understanding, their learnings, their findings. And that was the whole intent of World Wide Web. So he announced World Wide Web, and in the same year, he also released the HTML1 specifications. The current version of HTML is HTML5, so that you could use HTML and start writing your document and share it with others. But how would you share it without a browser? How can somebody see it? So there comes a browser called Mosaic. That was the first widely known browser in the history of web. There was a lead developer in Mosaic's team, and he thought, hey, I could probably make a fortune. So he came out from Mosaic and he created his own company called Netscape. Netscape. This is the company which is given the complete credit for the birth of JavaScript. And JavaScript was created in 1995 in Netscape. So Netscape felt like, hey, we probably might want to give a little touch of a dynamicness to these static pages. So that's how Brendan Eich, whom you can see in the slide, he created JavaScript in just 10 days. Can you imagine? Like our sprint doesn't end in 10 days. Some of the sprint goes for 3 weeks. Some of the sprint probably goes for 4 weeks. Even in this agile world, can you imagine developing a language in 10 days? So Brendan and I developed JavaScript in 10 days. Initially, it was called LiveScript, but Java was happening at that point in time in 1995, 96. Java was booming up. So Netscape thought it will be cool to add that name Java out there. So they reached out to Java and then they got some sorts of trade thing has happened, trademark thing, and they started using the word JavaScript, and it was proprietary to Netscape. But the fun fact is it wasn't named JavaScript when they started it. It was called LiveScript. They changed the name to JavaScript, and that was a complete game-changing experiences for the users. The very next year comes the CSS. And W3C, by the way, has already been formed by this time. So my animations are going really crazy. So bear with me for a second. In 1996, it was the year of CSS, W3C, along with Libert Boss and William created CSS specification for the first time, because just looking at the plain simple document was boring. They wanted to add colors to it. They wanted to make the headlines bolder. They wanted to add the images look shiny. They wanted to add different layouts. And that's how CSS came. And that was the beginning of what we call as browser war. Microsoft, Netscape was really, really popular at that point in time because of all these fancy functionalities. And Microsoft saw an opportunity out there. And that was the first time Microsoft provided something for free. And that was Internet Explorer. But JavaScript was a trademark of Netscape, so Microsoft could not use it. So what they did, they reverse engineered the whole JavaScript. And they named it as JScript. And slowly, Microsoft's Internet Explorer became way more popular than Netscape. And this was bundled to every Windows operating system. So it was also free. And they also released it for Mac pretty soon. It created a lot of problem for the developers, but that's how Internet Explorer owned its share. Netscape was dying. And what they thought that, okay, let's open source everything, whatever we have. And that's how we got Firefox. All the source code of Netscape was open sourced, and in 2004, Firefox was born. In the very next year, Jesse James Garrett coined the term AJAX. I think you all have heard about this term called AJAX, but it was not just 2005. AJAX has existed since 1999. And once again, the credit goes to Microsoft. It was Microsoft Outlook web access team. They were thinking of some way that, hey, how can we render every new email instead of the user has to refresh the whole page? So they came up with their own ideas behind it. And again, there was nothing standardized. So Microsoft created something called ActiveX Object. It was an extension which you would install in your browser, and then only it will facilitate this asynchronous communication. But as I told you, Firefox came out in 2004, and AJAX was getting mainstream. And browsers came up with something called XML HTTP request. So AJAX stands for asynchronous JavaScript and XML. We don't use XML anymore, but the terminology still exists. And it was Gmail the same year. I think Gmail was released in 2004, and Gmail just ran with it. It was the first mainstream application to embrace AJAX and make it mainstream. And very soon, Google Maps followed it, and many other applications. The game changer, according to me, I feel it was jQuery. And that is why we have so many front-end developers today. Before jQuery, we had to write script targeting to Internet Explorer because it was not standard, target Netscape, and also Firefox was there in the market. So there are 3 browsers who are actually competing in that time frame, like 2004 to 2006. And every developer had to write 3 sets of script. So it is the year 2006 when John Resig, he was still a student, he probably found out an opportunity that, hey, we could probably abstract everything. And he creates an abstraction called jQuery, which takes care of all the different quirks of IE, Firefox, and Netscape, and it exposed an unified API like jQuery dot selector, and you could select. Prior to that, IE had a different syntax and Netscape had a different syntax, and so does Firefox. And that's how people started embracing it. Otherwise, it was a really, really tedious job to write for 3 sets of browser. And every front-end developer probably had their own abstraction. But jQuery was the first one to kind of mainstream it and release it to the world, and everybody started using it. 2008 was another important date in history of web, because that's the time when Google released Google Chrome. And why is it so important? Because Chrome was using a brand new JavaScript engine called V8. So Firefox has its own engine, IE was having its own engine. Google came up with their own engine called V8. This is their JavaScript engine. They were still using Blink. They were still using WebKit as the rendering engine, like which creates the render tree, taking the DOM and the CSS on. But when the JavaScript was getting parsed, they completely created a new engine called V8. And Ryan Dahl, who was a engineer, who saw this V8 and thought that this is the best for his project. And any guesses what could be his project? I already said his name.
Node.js.
You're absolutely right. So Ryan Dahl saw V8 and he creates Node.js, which was in 2009. So why did he choose V8? Why did he create Node.js? So the reason behind it, he was trying to solve a problem called C10K. Like your server should be able to handle more than 10,000 concurrent requests at the same time. And no server at that time was able to do it, because all the servers were multi-threaded environment. Like it was either built with Java or any other thing, which was working in a multi-threaded paradigm. So you will be having several thread pools out here. When the requests will be coming, whatever is the idle thread, they will be catering to this request. So you hit a finite limit with the thread pool. You could probably argue that, hey, I can increase the number of threads with a little bit of extra RAM. Of course you could do it, but how much? It will probably run out again. You have to add RAM again. So no matter how much RAM you add it will have a finite limit that it could handle. So Ryan wanted to use something which did not have this limit. And that's why he chose V8 and JavaScript due to its single-threaded, non-blocking IO pattern. And he created Node.js server. There is no thread. Whenever the requests are coming, it is getting processed in an asynchronous manner. So when in a non-block, it makes an IO call, which is not going to block the single thread. Like for example, you asked for a resources, show me this xyz.pdf. So it will make a query. By the time that will coming, it just created a event loop out there. When the request come back from the asynchronous processing from the IO operation, it tells the server, hey, I'm ready. Now give it to the user. Something like so. So you create a server from the HTTP module. You just request the HTTP module. You call the function create server on HTTP module out there, and you pass a function. So this is really, really important if you have never seen JavaScript. Even Java today had it. So in JavaScript, functions are first-class citizen. So you can pass a function to another function. And this is the whole notion of higher order functions. So you can pass a function to anything, a function can return a function, and so on and so forth. So you are passing a function to create server, which has 2 arguments called request and response. I'm not doing anything with the request in this mode, but you could totally do something with the request and validate whether the request has been authorized, like if there is a valid cookie or not, the user should see it or not, and so on and so forth. What I'm doing here in the response object, I'm calling a method called write, and I'm just passing an arbitrary string called hello world. It could have been a valid HTML. Then I end the response. And this server is listening on port 8080. That is the standard port which we generally use, but you could use probably any logical port. When we put these things together, so you can see the same example which I have called server.js. In the terminal, I just started the server, which is telling the server started at localhost 8080. And on the right side, you could see when I access localhost 8080, I get hello world. But you probably can ask me a question, hey, is this an HTML? You're not passing an HTML, you're just passing an arbitrary string. But in the previous sections, when you're talking about, you said it needs to be HTML. So this is also a valid HTML. If you inspect the source code, you will see the browsers are smart enough to wrap it in HTML tags. Like it already created an HTML node. It also created a head node, and you can see there is nothing in the head node because I did not provide anything. And it wrapped the whole thing in a body tag and also with a pre tag out there so that this is getting printed. So you could very well just write a document called index.html and just write your name and open it in a browser. The browser will display your name. It will put all the remaining tags around it. Excuse me. So we saw how you can create a server in Node.js, but does that mean you will create your server every time? Is it not tedious that if you have to create your server every time? And for the same reason, we have a server called Express, like how you have Tomcat in Java world, or JBoss, WebLogic, or Apache HTTP for PHP server, or IIS server for .NET. You have Express server for Node.js. You could use Express server and get up and running with any application. Any questions so far?
I think you should pause here just for a quick, maybe 30-second bio break for everybody, Sir Botham. For those of you who are coming from non-technical backgrounds, I think the last few slides might have been a little heavy. So we'll just let them digest this. Guys, any questions for Sir Botham? So Sir Botham, maybe you can just go back 2 or 3 slides where you showed us about Node.js to begin with,
Sure.
and the architecture. And the yeah, right here, and then go forward slowly. From this point on, can we go to the next slide? Where you the next one? Yeah.
The next one.
Yeah. So these two are the heavy slides, right? The multi-threaded server and the next one. Yeah.
Yeah. So we can let me go through this multi-threaded server again. Let's take a real-time example. Like you have a Tomcat. You have a Tomcat server which is running. So you probably, if you're from the Java background, you probably have written a servlet out there. And when this servlet get deployed in the Tomcat, it, excuse me, the Tomcat server itself has multiple threads that it can spawn. Whenever the requests are coming, every thread will invoke the servlet again, and it will start responding. So you have finite thread pool. Similarly, you did have DBA pool, database connection pool at that point in those days. Like you will be making a connection to the database with JDBC, and you'll be having those pools. So pool is nothing but like pool is a pool. You have so many spare resources out there. Whenever it is needed, you can just pick one from there and start responding to those resources. But the biggest concern is that no matter how big is your pool is, it is still a finite. So there is a high chances at some time it will hit its limit. So that's the main concern of multi-threaded server, which created a problem called C10K. So hypothetically, no server at that point in time was able to handle 10,000 requests at the same time. It's not like 10,000 requests per second, 10,000 requests at the same time. And that's how Node.js started, which is a single-threaded model. So let me go through Node.js, how things are happening. So let's look at the first request. The first request came, maybe the first request was asking for javascript.pdf. So the server doesn't have the PDF with it. Server has the PDF somewhere in the file system, or maybe in some API, or maybe in some database. So the server will try to look for the PDF in its file system, and this whole operation is asynchronous. So in JavaScript, most of the call is all asynchronous. So what the server will do, it will tell the file API, hey, I need this file system. If you get this file, call this function. So something like, let's take a real-time example, like maybe me and Suva, we are friends right now. So I need something from Suva. I asked him, hey, Suva, can you get me this presentation done? So one thing I could do, I could keep calling him in every 5 minutes. Hey, are you done with the presentation? Are you done with the presentation? Are you done with the presentation? I could keep polling for it, or I could tell him one thing. Hey, Suva, you know what? I am out of the Slack right now. I'm going for a walk. This is my phone number. Could you do one thing? Once you're done, can you text me? So it is something like that. So JavaScript, what it is doing, it is telling the file system API, hey, go and search for this file. Once you get this file, call this function. And that function has the response object. And the moment that function is having the file system stream, it will start responding to the server, to the user. And that's how the browser will start rendering. Let's look at the request number 2. So the request number 2 is probably asking for, do I have new feeds in my LinkedIn profile? Do I have new feeds in my Facebook profile? So you are doing you are probably doing a scrolling. You're scrolling down your feed. So you reach certain extent. I made a request to the server. Hey, do I have more feeds that I can read? So server once again will go and ask the database this time. Hey, do Sarbotham has new feeds? By that time, if another request comes, it will start responding this one, because now the server doesn't care about it, because it has given a function to the calling function, which is calling the database. And then once that is done, it will respond, just like how Subha will call me or text me once he is done with my presentation. But we can go over Node.js one day. It might be too difficult for today to cover Node.js, but I just wanted to give a very brief overview how Node.js and Node.js server and traditional web server and application servers are different. The main concept of single-threaded non-blocking IO versus multi-threaded pool. But we can go over in a follow-up session if it is needed. It itself might take a whole session to talk about the non-threaded IO. When I did JavaScript for the first time, it wasn't easy to understand the callback pattern. So I don't really expect anyone who is not working in the front end to grok it at the very first time. So, and that's totally fine. Don't worry about it. We can do follow-up sessions. Subha, are you there with me?
Yes, yes, I'm here. Continue on, Sarbotham. I'll just pause maybe if others have any questions for the content
Sure.
we've covered so far.
So we were here. We were showing how to do with Node.js server and how it can respond. And we are also talking about Express. So this is where we pause. I'll take a pause for maybe 2 minutes before we jump into other things. I'll probably take a little bit of water. And also this gives an opportunity if you guys would like to ask any questions. Okay, fine, we'll resume since there are no questions. So Node.js, it is not just limited to creating these servers. It has created a new era of an abstraction. So whatever earlier the tools were being written in different languages, you probably have remember, like when Swing, I think, when Java was coming up with Swing, every application was built with Java Swing so that it can run in multiple systems. It doesn't have to be tied to one architecture, that is with Mac or Linux or different kind of Linux or Windows. So you had the abstraction layer of Java, and then you build whatever on top of Java, it will run everywhere. So Node.js also kind of gave the same concept. You get the Node.js in your system. Once you install Node.js, you can start running Node utilities on top of it. And it changed the whole developer workflow, at least for the front end. These tools like Webpack, Yearn, NPM, ESLint, these all are built with JavaScript, and these all are built with Node.js. So Webpack, for example, if you're working in a React project or maybe a Vue project or even Angular, Webpack is probably the de facto, which takes care of all your JavaScript bundling, transpiling the latest JavaScript into the older JavaScript code, bundling them together, splitting the bundles, and so on and so forth. So it takes care of your whole dev workflow. Yearn is the package manager. How you have in Java world, like the Maven or Gradle or Ant or Build. So Yearn is pretty similar to that in JavaScript world. So you have all your dependencies listed in something called package.json, which is the meta file in Java, and used to have something called build.xml. So we have these dependencies listed in package.json. Yearn will go through this package.json and will pull all the dependencies from the artifactory, that is the npm.js. ESLint, it is a type checking, it is a static linter for your JavaScript file. Like, are you adhering to the styles of your community, your company, your project? Are you specifying all the needed punctuations? Are you using the keywords properly? You are not abusing the JavaScript as a language. That's what is ESLint for. And we have many more tools. It would be too less of my screen to cover all of them. So I just took few of them. If you just search for Node.js binaries and tools, you will find tons of them. But even with this Node.js evolution, you already have seen this is 2010, and we started from 1991, and this is 2010. It's almost like 19 years. So many things has evolved by this time. But even then, this screenshot, I took it day before yesterday. It's in 2020. Even then, you see this kind of disclaimer. This site is best viewed with a resolution of 1024 versus 768 or higher. But things will be changing pretty soon in 2010, because something really, really important has happened already in the history. In 2007, Steve Jobs came up with iPhone. And this was the most successful and popular device which got web into this form factor. This was the first time. Prior to that, we also had touch-enabled devices. We also had semi-smart devices, but nothing was like iPhone at the game-changing capability. With iPhone, pretty soon we saw iPad followed it. Different screen sizes started coming up, different laptop sizes, different monitor sizes. And soon there are a hell lot of devices where the web had to fit properly. So not every website was fitting properly out there. And that was a time when Ethan Marcotte wrote an article in A List Apart, and he coined the term called RWD, or responsive web design. What is responsive web design? So responsive web design says, like, you write the code once, and that code will fit in all the viewports, all the form factor, whatever is available. Like, it will retrofit. I shouldn't use the word fit. It will retrofit, and it will change itself. It will adapt to itself. It will respond to the viewport size changes and viewport layout. So the same site, which is looking really, really nice, and with all the information in a bigger monitor, will also look nice and accessible in a smaller handle devices, and also the sizes in between. So for example, if you go to this site called mediaquery.es, you can see a list of sites with their screenshots taken in different dimensions. Like, you can see how it looks in mobile. In the portrait mode, you could see how it looks in tablet in a portrait mode. You could also see it in a bigger tablet. And then you have the larger widescreen monitor. But it doesn't end with only these 5 things. You could have multiple more sizes if you want. But standard practice always deals with this 4 to 5 dimensions and 4 to 5 sizes as of now. For example, these slides, like, you could write your style sheet for a device which is 576 px wide. You could have another overriding styles for devices which are a little bit wider, 768 px, and similarly for 992 and 12,000 px. And you could have many more. You could have many more breakpoints in between. So these numbers are called breakpoints. Like, you are telling the browser, hey, once the viewport reaches this width, do something differently.
That's fine. I think Sarbotham just needs a second to catch up. Sarbotham, that's definitely fine. If you need a water break, let us know, please.
Yeah, sure, no worries. I'm fine. So I was talking about the different breakpoints. So you can have multiple breakpoints to cater to your needs. Like, we don't know, tomorrow we could have maybe web will be available in the Apple watches. I haven't seen so far, but if it is available in the watches, I don't know how the UX will look like, but maybe you need really, really smaller mean width out there to retrofit your content in that form factor. Or maybe tomorrow we can have a really, really giant screen. So you just don't want to zoom everything. You want to put more content. So let me go one slide back and what I am talking about. So let me, oh, something happened. Okay, let me go one screen back. So if you see very closely, if you see all the screenshots, or this is not just zooming the content, right? It is retrofitting the content. If you see in the mobile view, it has brought down everything in a vertical layout. Now, the moment you go to a little larger view, you can see that there is a graph which is popping up in the Mozilla side next to the dog picture, the pug picture. If you go to a little bit bigger size, you see another picture which is coming up and the dog has moved up. So this retrofits and it arranges itself accordingly. So you are not losing any information, neither you are just zooming it out. It's not just zooming or losing information, but changing the way how the information has been laid out. So that's what we do with media queries. And pretty soon we are getting something which is not mainstream. We are getting something called element queries. So far, with media queries, we are targeting the viewport width and viewport size. But pretty soon, we will be able to target one particular element's width, one particular element's height, or something like that, which is still in the draft mode. It hasn't been finalized yet, but pretty soon we'll have that capability. So web is really, really evolving very fast. So the next question can come to your mind. Do you really need to code them by hand? Like even today, do we really need to do it? You probably don't need to do it. There is a library called Bootstrap, which comes up with some predefined styles. But yes, if you would like to override them, you probably have to hand code them. So as Bootstrap's definition says, that this is the most popular HTML, CSS, and JavaScript framework for developing responsive mobile-first projects on the web. I am really not sure if we can call this framework. To me, it is more like a library. I think we all have our own definition of what is a framework and what is a library. To me, Bootstrap is more like a library. I cannot do each and everything with Bootstrap. On the contrary, I would probably call Angular is a framework, Ember is a framework. React is still like a library to me. It is only catering to one particular need. So it's up to you how you want to call it, but you cannot just have a web application just with Bootstrap. It can cater to some needs, but not the whole applications. And let me take a moment here to differentiate between what is web pages and what is application. So when I was talking about the history and how the web was conceived initially, it was for sharing documents, only for sharing. And that's how we still call it web pages. And in those days, it was web pages which were getting built. In 2020, I shouldn't even say 2020, it's by 2011, 2012, we were no longer creating web pages. We were creating applications. And there has been a transition from web page to web applications. So with Bootstrap, you can still create web pages, but you won't be able to create a web application, full-fledged web application. You probably either have to build it by your hand or use the available frameworks which are there in the market. So slowly we transitioned into something called single page applications. Even if you have not heard about this terminology, I'm pretty sure you are used to this technology every day. If you use LinkedIn, if you use Facebook, if you use Twitter, if you use any new social media things, if you use Gmail, if you use Yahoo Mail, you all are using single page applications because this is mainstream. So what does single page application stands for? So single page application says, let's not even talk about single page application. Let's go back to the original era of web development. So every pages used to make a request and used to get a page. So we are talking about web pages as of now, not even dynamic pages. So you make a call for my bank page, you will get the login screen. You will enter your user ID and password. You will hit the submit button. That request will go back to your bank server. The bank server will validate everything and will return you with another page, which is your probably the dashboard. Now you look at your dashboard, you have multiple accounts. The bank is showing you savings, check-ins. Now you want to learn about your check-in balance. So you click on a link, the request goes to the bank server again, and the banks come up with another web page, which is a brand new web page, which shows about your check-in accounts details. But if you see this whole pattern in this, all the web pages, what are the views which are changing? The bank's footer, the bank's header, maybe the sidebar information, those are not changing. Those are still being the same. Only a small portion of the page was getting changed. Small portion of the UI was getting changed. So people also figured out about Ajax by at that time. They thought, okay, why to render the whole pages every time? Why can't we make a call to the server and only get that information, whatever is needed, and paint it in that particular area? And that's how the single page application started initially. As I was speaking about Gmail, like whenever you will get a new mail, that email will pop up at the very top of your mailing list, and you don't have to refresh the pages. So in single page application, there is no page refresh. There is only one time page load. So you make a call to the server, maybe you are calling to my bank services, you get a page, you get the same interface where you need to provide your user credentials, the user ID and password. You hit the submit button. This time, the whole page does not get submitted. On the contrary, there is a JavaScript which is hooked to your page, which is listening to the user interaction of that submit button press, and it prevents the form from being submitted and makes a asynchronous request to your server with the user credentials and validate that are you really eligible to access this page or not. If the server, considering you are the proper user who entered the proper credentials, the server will respond you back with some success message that, hey, this is successful, the user can see the pages. Maybe your server, your client side application on receiving a success message can make another call, hey, give me the view of the dashboard. So the server gives the payload with XML, it used to be originally, but nowadays we use JSON. But JSON is another document structure where you have key value pair. It is called JavaScript object notation out there, and you paint it. And that's how single page application started. Today, if you see Facebook, LinkedIn, and Twitter, just take a look at it. You just refresh the whole page once, no matter whichever link or button or any CTA you are interacting, it does not refreshes the whole page, but a small portion of the UI. And that's why it is called single page applications. There is one page, not multiple page, and the portion of the pages are just getting changed. Once again, Gmail and Yahoo Mail was the pioneer in doing it. So Gmail was completely client-side driven single page application, even till date. Like if you use Gmail, try accessing it. And for the first time, like if you have closed your browser and you open it up, you will see there is a progress bar, which shows you that, hey, we are loading the assets. So Gmail client is loading all the JavaScript, which is needed to render the application. And then it starts fetching for the data and rendering the Gmail. On the contrary, what Yahoo Mail did, when you, I don't know how it works today, but back in then, when you used to make a request for Yahoo Mail, you used to still get the HTML back, the bare bone HTML, where you can see what is, how many mails you have got, how many unread mails is there, how many alerts are there, how many chunks are there, and so on and so forth. And if you would start interacting with them, they will just behave like older applications. Like every link will make a request to the server. But slowly, as the application renders, this application will start making requests for the static assets, that is the JavaScript, which will come and start enhancing the applications. Like maybe if you just wait for 2 seconds and then click that button, it will not make the whole page refresh anymore, because by that time, the JavaScript got loaded and hooked up into your HTML. How we saw when we are doing that hello world example, like when you click the click me button, the JavaScript was hooking up. By this time, JavaScript has already come and hooked into the application. So this time, when you interact with any element on the page, it's not going to make a full page refresh, but it will make an asynchronous call and will get the data needed to paint for that particular scenario. As you can see, this could be tedious pretty soon. Like every time you have to write something on your own. Okay, this is how I need to do it. That is how I need to do it. You did it for Yahoo Mail, you did it for Gmail, but Google has many more products like Gmaps, for example, or maybe Google Keep, or maybe Google Drive, Google Docs. Similarly, Yahoo has so many things. Is it worth to repeat this every time you are doing something? It's not actually. If you have already done it, why to reinvent the wheel? And that's how the framework started coming up. Lots of JavaScript frameworks is available today. The very first one, which was popular, was Backbone. It was done by the same person who created CoffeeScript. I'm not sure if you have heard about CoffeeScript. There was a time when CoffeeScript was pretty popular. So people did not write code in JavaScript, but they wrote it in CoffeeScript, and then they compiled the CoffeeScript to JavaScript. You probably already have sensed it, why they named it CoffeeScript, because it's all because of Java. So Java was a brand of coffee, so they didn't want to call it JavaScript, and they called it CoffeeScript. So that was Backbone. I'm not sure if anyone uses it anymore. Pretty soon we saw Angular, Ember, React came in 2013-ish kind of time. 2015, we saw another framework. It's called Vue. And last year, I think, last year or last to last year, another new framework which came into the market, it's called Svelte. So they all are trying to solve similar problem, but in a different way. And they have their own notion of doing things. So I see the comparison out here, like jQuery versus React, how jQuery became popular over the time. So React has also become the most popular framework among all of them. We call it framework. Once again, I personally think it's a library. It's just attacking the view part of it. It's not taking care of your data management, how you get the data and how you render them on the page. So things are really becoming complex. And then the React team came up with something called Create React App. So back in 2006, 2005, or around that time, like if you really have to do web development, all you needed a text editor and a browser. So in the text editor where you can write your code, the HTML, CSS, and JavaScript, and a browser just to render them. But over the time, things became complex. You do not write plain JavaScript anymore. You are writing in the newer syntaxes, which browser might not understand. So you have to transpile them. It is not compile. So in Java or C or C++, we compile the languages. We compile the languages according to the architecture of the box where it will be running. So if it is running in, it will be running in Linux, we have to compile it with a compiler which understands that architecture. Similarly for Mac and Windows. But JavaScript is an interpreted language. So the way JavaScript runs in browser, so browser keeps on reading one line at a time. The moment it has read one line, it has found a delimiter, it has found a punctuation, it will start executing it. It will start putting it. So it reads and executes as and when a block of executable can be done. So what transpilation means, you can write JavaScript in the newer syntaxes, which are still not supported by any JavaScript engine, whether it is V8, SpiderMonkey, or Trident, or any other JavaScript engine. So what you need a tool which will intercept that code which you have written in the modern languages, and it will transfer it into old compatible syntaxes. So we have those kind of things, which is called Babel. I have not included them in the presentation because it could be overwhelming. And what this Create React app does, it abstracts everything for you. You do not have to worry about how to scaffold a React application. What are the files you need? What are the directory structure you need? How to set up your build script? How to set up your dev workflow? You don't have to do anything. If you see in the screen, they're already calling it out, like it's a zero configuration build tools. So if you are a JavaScript developer, haven't tried React, that's very unlikely. You probably have tried it. If you're not a JavaScript developer, just give it a try. Just try the Create React app, and you don't even have to code it, but you can see how fast you can just build up the whole thing and how well you can get started. So React made a concept very popular, which is called React Component. And we also have similar notion in vanilla web called web components. So what is a component? So component, like if you see this screenshot, which you are seeing right now, maybe that clone or download button, which is at the center of your screen on the right side, that itself could be a component. Or the bar which you see at the top, which is kind of yellow and then a green, which is showing what is the kind of language this repository is made of, that itself could be a component. Anything could be a component, like used by that entity could be a component. Like my profile picture in a drop down, that could be a component. So everything could be a component, and you put these components together to create a web applications. So I like to think it in this way. These components are nothing but consider them as a Lego blocks. So you have these Lego blocks, and we both can have these Lego blocks and can create something different from there. So you compose them, you put one on top of other, or on the sideways, on the left ways, on the right ways, and you come up with something, a fascinating structure. So even the same thing holds good in the web. So you have these components, whether it is React component, whether it is web component. You also have component notion in Ember, but they don't play, excuse me, they don't play well together with each other. You probably have to use the same ecosystems frame component, but you use this component and build up this wonderful structure. And with these components, with the Lego blocks, you create a Lego structure. With components, with web components, React component, Ember components, you create a web application. So let's take a quick look out here. So this is my LinkedIn profile page. I just highlighted few of the components out here. So if you see whatever is getting highlighted, they all are components. And there are many more components which I have not highlighted. The whole application itself is a component, which is composed of many other components out here. The one component which is of very particular interest out here is this search box. You might have seen this in tons of web application, whether it is LinkedIn, Twitter, Facebook, or Google. Like I just put the Google at the end because they made the search so obvious. Like you have this search everywhere. And this looks so common use cases, like to build a search autocomplete, search type ahead, or search box. So this could be a very typical example of an interview question. Like if you are appearing for a front-end interview, you might get asked about like, hey, design an autocomplete, or design a type ahead, design a search drop-down component, or implement a search component. So this could be a very typical interview question. So when you get this kind of component, this kind of questions, the first thing, maybe the interviewer can give you a demo, how it should look like. For example, here you are seeing a demo, like I'm just typing SAN and I get a list of suggestions out there. I can use my up and down arrow keys to select them. And when I select them, they gets highlighted. I can also use my mouse to select these options. And I can, once I select something, once I highlight something, I can click on them and select it, or I can press enter to select them. So this could be an example of type ahead. So the interviewer can probably give you a demo like this, or they can just tell you what I told earlier. And you have seen this component or UX pattern so often that it's totally fine to feel excited and get started with this. So if you feel excited, nothing wrong on it. You might feel the adrenaline rush, which is going through your veins. Like, hey, let's get this done. I know this thing. This is so easy to crack. I'll just do it right away. But as Suva was saying, if you attended yesterday's session, stop. Don't do anything. Don't start coding. Don't start design. Take a pause. Take a step back. Ask yourself a few of the questions. Like, do you understand the requirements? Have you understood each and everything what the interviewer is asking? Think out loud. Like, think completely out of the box. Okay, what am I supposed to do here? What are the corner cases that can come? Has the interviewer clarified everything? Because these questions can be vague and ambiguous, and oftentimes these questions are vague and ambiguous on purpose to see how you can understand and get more from these things. And if you have to if you're in a discussion, like if you're in this company and if you're discussing with your PM, like the PM just comes up with this notion, hey, you know what, I want to build this component out here, can you add value to this discussion? Can you bring up your concerns? Hey, this can be done, this cannot be done, these are the challenges which we might see. Can you think about all these things? Can you clear the ambiguity? That's what is another aspect which is being validated in the interview when you're doing it. Not just coding. Coding can be done like if you like if you're really good at coding, if I give you the clear requirements, you'd probably just crank it out. But can you decipher the requirement? Can you get out of the situation on this ambiguity? So definitely ask clarifying questions, and the more clarifying questions you ask, the more weightage you are given on your interview. It's not considered as a bad thing, it's really considered as a good thing, the more questions you ask. The next question you should ask yourself, because interviewer will probably not tell you, that is this a single problem or there are multiple problems in tandem? Am I being asked just to solve one thing, or am I being asked to solve a really complex thing which could be broken down into multiple smaller problems? So ask this question, like, can this be isolated? Can the problems be isolated? Because this is another skill, not only problem solving, but how you can isolate the problem and you can tackle them individually. But it also brings up a challenge, like how you define the APIs, how you define the interfaces. So all these small pieces will work very nicely with each other. And these are the things which are being given lots and lots of weightage in an interview. So maybe by this time, once you ask all these questions, you will probably have a fair understanding of the requirement, what is being asked from you. So start with a very high level abstraction, maybe 50,000 feet. Okay, type head component, right? So what are the basic use cases? The user will type something, I will make a query to the API will give me some data, some response, and I'll display it. So maybe this is the very, very high level abstraction. The next question which should come, the edge cases. How often should you make the request? Like I just started typing A, should you make a request? If you make a request with A, in what order the response should come back? I just started typing APP. Should you start making a request then? Talk to the interviewer. Hey, what should be a basic time gap that I should give? Because I might be typing really fast. I know how to type without looking at the keyboard, and I'm typing really fast. Do you keep making requests on every keystroke, or do you wait for number of keystrokes, or do you wait for the lapse in time between keystrokes? How often do you call it? So this is a very, very important aspects of performance. So you have to also consider that one. So consider all the edge cases. What if there are no requests when you are making? What should the fallback UI should look like? Maybe the designer haven't thought about it. Maybe the PM never even thought about it. What is the failure scenario? How it should look like? Ask these questions. And once you have created a very high level API, still now, don't start implementing or design. So far, you are probably making some diagrams on the whiteboard, or if it is a virtual interview, maybe in some Colab scratchpad somewhere. Once you have the idea how you want to do it, discuss it with your interviewer, and don't consider it him or her as an interviewer, but just consider it as your colleague. Like, okay, you are discussing a problem and you are trying to come up to a solution. And you cannot, in this industry, you cannot just come up with your own solution. You have to either convince everybody out there, or you have to get their buy-in, or you have to understand what the other people are doing. So again, it's not just coding, but how well you can be aligned, how well your thoughts, how well your approaches is aligned with the whole ecosystem. In that moment, your interviewer, one or two, so you have to be very, very aligned with them. Discuss it with them. And if the interviewer gives you some hints, take that hints and try to re-articulate it. Speed matters, but just for the sake of speed, don't miss these important opportunities, important steps. Discuss it, reiterate on it, discuss it again with the interviewer. So eventually you will probably get a buy-in from the interviewer if you both are going in the same track. And in order to go to the same track, you need to practice a lot. So you will understand what is being expected, what are the best practices. But please don't start implementing without doing all these steps. You have to have a buy-in from the interviewer. You probably have done the whole design or the coding, and maybe you and your interviewer are just poles apart. So that ruins both of your time. So please don't do it. Get a buy-in from the interviewer. Sometimes interviewer would probably not give you enough hint. Maybe they will just be, okay, you do it. I'll see how it works. If you feel free to do it on your own at that point in time. But other than that, please always get your interviewers buy-in. Hey, I'm thinking in this way. Do you think this is right? Then only do it. So once you and your interviewers are aligned, that is the time when you start designing, if it is a system design interview, or this is the time when you start doing, implementing your coding challenges, if it is a coding interview. But so far, that doesn't mean you are just talking. You use the whiteboard, draw something, give the high level picture, and do it. So once you start implementing, I think once you start implementing, by that time, you probably have already got buy-ins from the interviewer. And if it is a coding round, this is being evaluated how well you can translate your thought into code, which is also very important. Try to be on the time. But even if you are not on the time, this is one thing which I have observed. If you have designed it really nicely, if your APIs are really nice, if you have modularized it, like, okay, these are the, in type ahead, these are the many functions I'll have. For example, I'll have a render function, whose job is only to render the options which will come. So this guy doesn't worry about data fetching. So you could have one function which will just do data fetching. It doesn't worry about how this function is getting triggered. You could have another function which is listening on the key presses, like handle the key press. And depending on those criteria, this guy calls the data fetching. Data fetching is done, then you call the rendering. So how well you articulate these sequences and how well you modularize, excuse me, that gets really higher weightage. If you have done this thing, and if you probably could not complete the whole implementation, still this is fine. But do these basic steps, just like our maths, like you just don't do the answer, you go through every step. So once you got here, you probably know what you're doing. Go ahead and start designing or implementing your component. This should be fairly easy or fairly, depending on the time. But if you are able to complete it, before telling your interviewer that this is done, take some test cases, run it by yourself, take some test input scenario, take a happy path and see how it is working. Take a non-happy path and see how it is working. Take some boundary conditions, run it by yourself. Only when you are satisfied, you think this is happening, then say your interviewer, I am done. Maybe both of you will run through the code again, and that will give you a much better outcome. So follow these steps. This will help you to crack your interview. Many a time you will not know the problem, even if you go through the coding, cracking the coding interview, all lead code, like there are tons of problems, but most of the time the front-end interview, this will happen from your experience, like what you have seen, what you are doing. It will be very real use case. Like for example, which I showed a type ahead, or maybe something like how do you define Facebook's infinite scroll, like as you are scrolling, because that's a very common pattern any social networking site you see. So this will be very real time. But again, I'll try to iterate one thing. When you get a problem, try to identify if there are multiple problems or not. Is it a single problem or there are multiple problems? For example, this type ahead, I'm not sure how many of you anticipated it, but there are tons of sub problems out here. This is not just one problem. So to name few of them, one would be, how do you develop this utility so that it can be customized? Like you are a library author, like Bootstrap or something like that. So you created this type ahead, but I don't want the highlight to be in blue, how you showed me. I want the highlight to be in yellow. How easily can I do it? Okay, I want user to select multiple options. How I can do it? Like there should be fields out here. Okay, I don't want user to display the text which is selected. I want the moment user clicks on an option, it takes the user to a page, like it's a Wikipedia page which we are discussing, right? Which we showed. So if the user clicks on San Francisco, the user should go to the San Francisco pages. How you do that? Think about composability, which I already talked about. Like, can a type ahead has a type ahead inside, which is an anti-pattern, nobody will do it. But is it possible? Is your architecture flexible? Can I do that? Can I compose it? How about performance? Like, if I'm doing the search, is the other things, if I have tons of animation which is going on my page, the are they getting affected? Like, are you choking the network? Are you choking the main thread? JavaScript is a single threaded model, so we do not have multi-thread out here. If you have a long running process, you will have jank. It will be a very, very bad user experience. So have you taken care of that? So when talking about performance, have you debounced it? So debounced is like, okay, I'm typing very fast. You don't want to make network request for every key press. So you probably give some amount of time and then make a request, network request to get the data. So that is debouncing. Throttling is also like, maybe I'm just scrolling down, boom, 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 I'm scrolling down. Like, when do you make a call? Like, do you start calling on the very first scroll, or do you have some sorts of threshold? Like, okay, if the scroll is reaching to the end of the viewport, then only I make a call. How much do you want to cache so that you do not have to make call every now and then? How your request payload should look like. If you're going for a front-end interview, probably will not have to design the backend API, but you definitely have to design the payload, the request and the response, how the response should look like, because you, as the consumer, we will be using that data and display it. So you will definitely have to identify what are the important things you need from the response schema. For example, let's go back to our type ahead example, which you have seen. Like, you are typing the Wikipedia search, you typed San. So San Francisco came. What do you want to do with San Francisco? What happens when I click on San Francisco? Maybe the product can ask, like, this could be a people search. Like, I'm searching for people in Facebook. So when I click on the search result, it should open up the profile page. And how do you open up the profile page? You definitely have to have some identifier to identify to open up that page. So your response schema, when it is giving you those options, it should probably give you an ID or some kind of URL, profile URL, or some other information. Think about it. Just don't think about the use case, what you have been asked for. Think about the use case beyond that, what it could be used for. What is the purpose? Why do I need to, what do I do with these options? When the user selects an option, what happens? So that's the question. Think about usability when you're doing UI. It's must, because there are so many people with different abilities, so many people with different challenges. Like, can I use your widgets with keyboard? Can somebody use it with something else? Is it legitimate? Like, can I read everything? Is the font readable or not? And last but not the least, please take care of accessibility. Like, think it, this is really, really important when you're going for UI interviews. Like, how would a blind user, how would a visually challenged user will interact with your UI? How a user who has motor disabilities, like who doesn't have fine motor control, like who cannot use a trackpad or mouse, how they're going to use your UI. So once again, you and I, how the user is using what I have created. So always keep it in mind. And then once you have followed these steps, you get your component done. You can do what you want. Your component is done and you are all good. Talk to your interviewer again that, hey, this is how the whole thing is working. I really cannot see anything beyond this. And it doesn't end. It does not end out here. So your interviewer might say something, oh, you have not taken care of this thing. You could totally agree to the points if it looks valid and say, hey, this was MVP 0. I was thinking about doing it in the next iterations. So iteration is really, really key in the software industry. In today's time, in very, very crucial. Like, you just don't want to do something big bang. You do in a very incremental step. So your development should also, your development, your intent, your design should also reflect that. So tell them very clearly, yeah, I wanted to design it in such a way so that I can retrofit all these use cases. I can expand it to those use cases. Just don't say, I haven't thought about it. keep an open mind and think, like if maybe you have not thought about those use cases, but if that use cases comes up, challenge yourself. Oh, I haven't thought about it. Maybe I will change this implementation a little bit, then I can think about it. So think about those use cases, and hopefully you will do really, really great in this kind of interview. So what kind of resources I generally followed, or I have followed? We have tons and tons of resources in the web today, but it's very difficult to find the needle in the haystack. There are a lot of redundant information. There is also not good information. It depends how you reach them. So few things I will suggest you if you are really going for JavaScript. These are the 3 books which are really, really good. The first one is JavaScript, The Good Parts. This book was first published, the first edition was in 2008. So almost 12 years back. It still holds good. I think if I remember correctly, it only has 80 pages. The pattern, whatever you will see in this book, still holds good today. And it will be a really, really quick read. You can finish it very early, but some of the concept might take a longer to grok. It is so concise, so it might take a little bit of time. In today's JavaScript syntaxes, many of the things might have changed. The syntax will look different, but the core concept still holds good. The next book was also published by O'Reilly and Yahoo Press. It was published in 2010. And this book talks about all different patterns. Like if you are coming from the backend development world, you are already familiar with all the different behavioral pattern, structural pattern, creational pattern, singleton, and so on and so forth, command pattern. How can you utilize those well-known patterns in JavaScript? Because JavaScript's model is completely different. It's not like Java, like you cannot have those classical inheritance. JavaScript has a prototypal inheritance. How do you retrofit all those things in JavaScript? This is an excellent book. Like I haven't seen a better JavaScript patterns book than this one by Stoyan Stefanov. This is really, really great. I cannot recommend anything better than this. And the last book which I have in recommendation, I think it got published last year or maybe last to last year. I don't exactly remember when. So this is also once again the first book I saw which talks about data structures and algorithm in JavaScript. So far, I haven't seen any other book that is talking about data structures and algorithm in JavaScript. Most of the books talks about Java or C++ or C. So if you are into JavaScript, this is really good book. This is very nice book. There are some errors, which was when I was looking into the book for the very first edition. So I also reached out to the author, Sammy. He's very cordial. So they're also maintaining a GitHub repo where they have the list of all the errors. So you can probably look at them and get it done. This is also a very nice book. And these are the 3 sites that I'll leave you with. This is excellent. Like MDN, which is the developer.mozilla.org. So this should be your single source of truth for any API, any usages. Is it supported in this browser? Is it supported in that browser? Anything with front end, this should be your single source of truth. So this was maintained by Mozilla initially, but in today's time, it is also contributed by Google and Microsoft. So they are the 3 key players in this web world. Like Google has Chrome, Mozilla has Firefox, Microsoft has Edge. It's no longer IE, which is also built on Google's Chromium engine. Apple is here, it has Safari, it doesn't have that much of a market share, but these 3 are the key players and they are continuously contributing to this knowledge source. So if you have any information you are looking for, go to developer.mozilla.org, and that is the best source of truth. You can probably read many other blogs, but everything should be based on this one, whatever you see. And the next one would be CSS tricks. So this is run by, there are many authors right now, but this is primarily by Chris Squire. So if you're in the front-end world, you probably know about him. He's a fantastic person. Like he has tons and tons of resources, especially you go to the csstricks.com/guides. It has definitive guide, like how to use the latest and greatest of CSS, like grid system, Flexbox. These are brand new technologies. I shouldn't say brand new technologies. Flexbox has been there for some time, quite some time, maybe 2014-ish onwards. Like it was getting mainstream. There are a lot of quirks, but you will find all those guides and resources. If you ask me how to use Flexbox, I'll be very honest, many times I forget many syntaxes. So I go to cssfix.com and I check it out there. It is not always possible to keep everything in your brain. And last but not the least, this is an initiative by Google. I believe the Chromium team, I'm not sure if there is any other contributors to this, but it talks about all the new things which are coming into the web. Like, can you read an USB drive? Can you take a picture? How do you use your media APIs? Can you screen record your screen, the browser screen? Can you do payment? Can you do authentication, a third-party authentication? Like, you do not have to do all these things by hand, which are coming into the browser. Like, these are getting seamless experiences, just how you would see it in a native applications. And the next stop for this web enhancement right now, I have not included in the site because we need a dedicated session only on that, which is called PWA, that is Progressive Web Apps. So Progressive Web Apps is trying to bridge the gap between native applications, which are in your phone, and the web applications. So you might ask, why do we care about progressive web apps? In the developing countries like India, Brazil, where the phone's memory is very, very expensive. People don't want to install your app. Like, at the bare minimum, an app will be 12 to 20 MB at the bare minimum. In 12 MB, if you are taking pictures of 2 MB of the size, you can store 6 pictures. You can store probably 2 music videos, 2 musics, 2 MP3 tracks, or maybe even a short video out there. Why would you install an app? So in those countries, people have seen a huge lift, like companies like Flipkart, Myntra, even Amazon in India. They all are going for their investing in their PWA so that they can get the market share. And that's the beauty of web. And it just doesn't end out here. The biggest benefit of web over thick clients and this application, like, if I have installed your app and if I have turned on automatic update, which most of the people do because they don't want to consume their bandwidth, there is no way you can force me to get the latest of your app. Like, maybe you have fixed a security vulnerability. There is no way you can force me to do it. You can probably tell me, you can send me an email, hey, there was a vulnerability, please upgrade your app. But without letting me know, if I have not have the auto upgrade on, you cannot just do it. But if it is web application, there is nothing on my side. You have the total control. You find a vulnerability, you fix it. Next time I access it, I just get it by default. And that's the beauty of web. With that thought, I would like to end here. I planned it for like 1.5 hours. I thought it might go a little beyond. I was thinking if we can have more questions in between the session, but since there are no questions, we are right on time, how much I kind of anticipated. And with that, I would really like to thank you all for attending, and BayOne for providing this forum, this podium to talk and share my learnings with you all. And thank you. And if there are any questions, we can talk about them out here. And I'll send out an email with the PDF version of this presentation so that all the links that I have shared, you should be able to access them. And yeah, it's open for any questions if there are.
So Sarbotham, this is Suva. Thank you again for a very enlightening session. And for most people, I think this session was very good, very informative. Some people might have found it a little heavy too, but this is good, right? That's with the right intent. And you've had a long session too. So let's just maybe pause for a minute. We'll let you have a quick water break, and then we can come back with questions. So folks, if you have your questions for Sarbotham, please hold them until he gets himself a glass of cool water. I know it's a very hot day outside today. And in the meantime, Sarbotham, if you can pass me the ball back.
Oh yeah, of course. Yeah.
Fantastic, fantastic. Yeah, thank you very much. Okay, so we covered a lot of stuff today. So any questions? Please feel free to ask your questions. I do have a lot of questions from my side as well, especially given the fact that our audience is very varied, right? Some of them come with very little programming experience. There are others who have a lot of experience, and there are folks who have experience on the back end side of things and are typically Java or Python programmers. And one reason we asked them all to attend today is that increasingly companies, organizations, as they build applications, you're not looking at something as a standalone front end only app or a back end only thing, right? At the end of the day, we are servicing the need of our customers or other companies. And in the process, we build applications that have multiple layers. There is a front end component, there's a back end component, there is a database. So as software developers or people who are facilitating software development, we need to understand what's going on behind the scenes. And your description today, Sarbotam, of how this evolved, right, since the beginning of the 1990s with the advent of the World Wide Web, the starting of JavaScript, CSS, and HTML, and how it progressed over into Node.js and even further into, frameworks and libraries, Reacts, Angulars, and so on and so forth, was very helpful. I think it was very intuitive for all of us. So folks, please start asking your questions. And even if they are simple questions, if you are interested in pursuing learning UI a little bit more, then please ask that question as well. And Sarbotam would be able to guide you in that front. So I'll just pause there. Please start asking questions. And remember, I think all your lines are muted. So if you want to use the audio bridge, just unmute yourself before asking the question.
Hi, Sarbotam. Shri here.
Hi, Shri.
So, thank you for all the detailed information about the history and all, but I have a quick question regarding, as you said, we have a different frameworks evolving every day, right? Whether it's a JavaScript or backend, how does a developer or an organization is picking up the change in the framework?
I think that's a great question. This is $1 million question which you asked, and this is very practical. First of all, thank you for asking this question, Shri. So when this new tools comes up, somebody is trying to solve a problem. Please let me reiterate, somebody is trying to solve a problem that might not be your problem or your company's problem. So a new tool doesn't mean that we have to start embracing it right away, right now. So let me give you an example of Yahoo. When I was working in Yahoo, so I was working for Yahoo membership code base, and Yahoo membership, like how you log into the system, how you get authorized, how your password gets updated, how you change your password, so on and so forth. That code base was 18 years old when I was working. Nobody touched that code base because there was no benefit in touching that till 2014, when we saw that, okay, now this is getting choked. We need to convert it into the modern stack, and we need to do it. So you validate, do you need it? It's not like, okay, this is the new thing which is came up in the market. Is it solving your problem? Like in LinkedIn, we don't use React, we use Ember. It's a different framework, but is Ember good for LinkedIn? LinkedIn has validated that prospect, and they found, yeah, Ember is the best suitable tool. So LinkedIn is using Ember, even though React is the most popular framework right now. So the trade-off between your need and what that framework is solving. Again, I'll say there is a new framework, doesn't mean you have to use it. Validate whether that framework is solving any use case for you. Like it could be an user's experience use case, like you want to enable or empower your user with this framework. Is it doing that? Is it going to bring developer ergonomics? Is it going to make your developers happy? Is it the skill set that is available? So it's a multifaceted challenge that you need to unpuzzle before you embrace any framework. But as a developer, I do try out new things, because if I don't try it out, I don't know what is the trade-off. Why React is better in this way, why Ember is better in this way, or like we are recently writing our UI automation test cases, which I'm also writing. So we have chosen Puppeteer, even though most of the test cases are being written in Selenium, because we found like we will be much more productive if we do it in Puppeteer, because that is just JavaScript, and we know JavaScript and we can do it much faster, which is looks like the UI thing. So once again, I don't think there is a definite black and white answer to your question, but ask this question: is this framework, in which way this framework is going to help you? Is this really solving any problem, or is it just the newest shiny thing in the market? Don't go for shiny things. There are a lot of gotchas when things comes at the very first time, because they haven't uncovered a lot of challenges which you might face with your use cases. So let it be a little bit stable, but as a developer, keep practicing it, but into your company. I'll give you another example, a very nice example. I was talking about ESLint in a while back, like when I was talking about the Node.js tool. So the main developer of ESLint is Nicholas Zakas. So he was working for Box when he already released the first version of ESLint. He, in one of his talk, he said he did not get ESLint into Box because Box was already using JS Hint, and getting this new technology would make a huge change in their whole developer ecosystem. So they didn't want to do it. He didn't, even though he was the owner and he was a proud owner of it, he didn't want to do it. So take a pause, validate whether you need it or not, and then only embrace it. Just don't embrace it because it is the latest shiny thing in the market.
Thank you for that. And also a quick follow-up question is, like, I know like at this time we are actually trying to move out of the role that we are in, like changing the paths in the career. So what would you suggest for now? Like, what is the best tools to become a UI developer at this moment? I know like each and every company has said you are using Puppet, or you guys are not using React, right? But maybe other companies are using it.
So the first thing, I think, again, that's a great question. That's a very valid, practical question. So Subha already covered few things yesterday. So right now, every company, nobody is looking for UI engineer. To be very honest, nobody is looking for backend engineer. Nobody is looking for, maybe in another 2 years, nobody will be looking for DevOps engineer. People are looking for multifaceted full stack engineer who can do anything, whatever is needed. Whether that is good or bad, that's a different conversation. We can have it later on. But unfortunately, that is the state of the scenario right now. You got to know your, if you're switching your career, no matter, even if you go to these companies as a front-end engineering interview, you will have your data structure and algorithm round. So please do that thing. And specifically talking about UI, if one book you can read, if not one, if two things you can do, please read the JavaScript good parts. It will give you the core principles of JavaScript, how the whole thing works, because it takes a little bit of time to understand what is single-threaded non-blocking. We can have a session just on that someday, but it really takes time. Like it's a paradigm shift. It's a mind shift. Like, oh, what is this single-threaded non-blocking IO? What is this callback pattern? That book will give you really, really good exposure, even though it is 12 years old. JavaScript hasn't changed. The methodology haven't changed since then. Please read that book. And for a framework, please try React, because you will get really up and running. That is the most vibrant framework right now. You have a huge community support. If you are stuck anywhere, if you go to Stack Overflow, maybe even before you type your question, Stack Overflow will suggest, hey, we already somebody typed this question. So try it with React. Please read JavaScript, the good parts. That should be the Bible for any JavaScript developer, even today. Trust me, even today, that's the best book. And if you want to advance your career, please read the patterns too. And then just brush up some of the articles. Just subscribe to CSS Tricks. It is, though this is called CSS, it keeps on posting many other technologies out there. Very recently, they had a series on how to get up and running with Vue.js. Like it was a complete series, like a 5 or 6 chapters. So those are the pretty good things you can try. But please don't underestimate your data structure and algorithm skills. Those are very, very needed, even if you're going for front-end interview. Please brush up those things.
Thank you so much. And sorry everyone for taking longer time.
No, Shri, that's absolutely okay. We actually want you to ask questions, right? We want to keep this interactive. The intention is to make you a better engineer, a better developer, or if you are looking to transition from a non-technical role into a technical role, we want to give you enough information so that you know where to start, right? So yes, that was a great question. Sri, in fact, do you have any other follow-up questions?
No, I'm good so far for now.
Okay, good, good. Thank you. In fact, Sarbotam, we have a couple of questions on the screen, but before you go there, so Poonam has a question. I think Deepa also has a question. But before you go there, there's a lot of talk about UI, UX, and people use
Mhm.
these terms interchangeably nowadays, right? So, and given the fact that a lot of us on the call are not quite UI or UX experts, could you spend just a couple of minutes and tell us what is the difference, what is the commonality, and why this whole user experience thing now? Is it the same kind of people who do UI, who do UX as well? Or is UX a very different, more artistic kind of a skill set? So if you could, throw some light on that. And then people with engineering backgrounds, like many of us here on the call, or even non-engineering backgrounds, what should we pursue? Who are better UI people? Who are better UX people? What is the difference between the two? So your 2 cents on that.
Sure. I think once again, that's a very, very, very nice question. So in a layman's term, let me just keep two things separate. When I'm talking about UI, in a very layman's term, this is my interpretation. Everybody has their own interpretation out here. When I talk about the UI, is how you have rendered the static pages, how you have rendered the button. Where have you rendered it? Have you rendered it above the fold? Can I see it, or do I need to scroll the pages? Is the font which you are using, and this is the place where it is very, very highly overlapped. Like both the places, the front-end engineer and the designer, and even for the UX, the front-end engineer and the designers, they're shadowing each other. So it's not just engineer and the designers, both are wearing the same hat. So when you talk about UI, we entirely talk about I personally feel it, the real estate of the screen. What all you want to show it to the user. Is it all prominent? Is it all visible? Like how many call to action should you have in your page? That line start a little bit fuzzing there. Like, is it UI or UX? Because now it is turning towards the experience. So UI, how you have laid out the content, the main content when you see, one funny thing which we have noticed, that no matter how much of text you have on the page, like if you have a pop-up modal which has two buttons, cancel and okay, nobody reads whatever is written out there. People are just looking for the escape hatch. So which side should be your cancel button? Which side should be your okay button? Now, if you are working with the mobile, most of the people, this is kind of a little bit biased towards right-handed people. Most of the people try to put the primary city on the right side so that you can you can tap it with your thumb of the right side. So that their lines becomes a little bit fuzzy between UI and UX. So UI, I personally consider it how you have rendered the static page, and UX when the interaction kicks in. Like for example, I'll take a real time scenario out here. I probably need to make a money transfer. How many clicks do I need to go through? Like, am I doing this transfer for the first time, or am I doing it recurring time? Like I probably have sent money to my mother. So the system should probably cache it so that next time when I come, like it can just tell me, hey, this is the last time you send the money to your mother. Would you like to transfer money again? So this comes the UX play, instead of the system telling you, oh, I don't care, I don't persist your state, tell me whom you want to send money, put all the information again and I'll do it. So there comes the UX, how pleasant the flow for me. Maybe the first time I take a lot of time to do that thing, but can system cache it? Or when I'm maybe trying to add a feed to my LinkedIn account, can it give me some auto suggest? Like this is a professional network. This is maybe a wish list from my side. So I'm typing something on the post. Maybe that word doesn't look really nice. Maybe I should use differently abled. Maybe I type the word handicapped, which is not a very nice terminology. Can the system tell me? So this all comes as a part of the UX. How well the button sizes are. That's again, the line is very thin between UI and UX. Is it really big enough so that I can interact it with easily, like I can press it with my thumb? Or is it really tiny that I can do it? Or is it really huge that it is taking all my real estate? So again, in short answer, when I think about UI, I think about the real estate, how well you have presented your information in the available real estate. And when I talk about UX, how pleasant you have made the engagement the user is having, or the interactions the user is having with your system. That should be my short overview, Subha.
That's wonderful, wonderful, Sir Bottom, and thank you for explaining it in such detail. That's a great answer. So let's go to Poonam's question
Yeah.
that she has asked on chat.
So Poonam from design. So Poonam has a question from designer's point of view. What would be helpful when interacting with a developer? The first thing will be like, consider you are a designer and I'm a developer. Let's sit together. You have the vision, and I probably can add more to it. Like, is it feasible? Let's talk with the developer that, hey, I want to do this thing. Is it feasible? Like, if you really go back in 2010, when CSS did not have gradient, and we used to gradient with a 1 pixel image and we stretched it. So we did not have rounded corners out there. If you would have been a developer, a designer at that point in time, and you would have asked me, hey, can you do rounded corner? I would say, yeah, sure, we could do it. But so much of effort, is it worth it? So designers can have a lot of innovative ideas that this is how, if I do it, it will look really nice on the screen. But is it worth it? But today, if you ask me to do rounded corners, it will just take probably 2 minutes, not even 2 minutes, 1 minute of my time. I can just give a border radius and it is done. But even till date, we do not have any native component for doing a drop down. So suppose you ask me, hey, you know what? I want to do a drop down where I'll have pictures of all the individuals out there. I'll probably take, is it worth it? It takes so much of time. So let's talk together, come up with your design. Don't compromise with your design. Because if you start compromising with your design, the innovation will stop out there. Go crazy, whatever you can think about it. But please validate it with your counterpart. Hey, is this possible? This is what I want to do. Is this possible? And you can probably come up with a very happy path out there. What is the best that you could do? And will website artist designers need this skill? Poonam, this is getting a little bit very, as you know, like as a system, as the technology is evolving, again, this space is getting that difference is getting very, very narrow. I know there are designers and there are tools also like Sketch. Sketch used to provide, like you could actually create all the CSSs from the Sketch file itself. So I have seen sometimes designers tried by themselves, and instead of even going to the developers, whether this is feasible in the browsers or not, even if you are not completely compliant with the latest technology, but at least having a notion what is possible, what is not possible, can save you a lot of time between the back and forth between developers, because you might not have that span. So knowing about what is possible and what is not possible will definitely give you a better hand on that. So if not fully, I would still suggest being aware of what is possible and what is possible easily, what is available by the platform, what is available on the native thing, like the developer doesn't have to reinvent the wheel. That will be very, very helpful. Does that answer your question, Poonam?
I guess, oh, perfect. It does. Thank you.
Perfect. I think the next question is from Deepa. What tools you use for testing UI? Deepa, currently we are using Puppeteer, which is a JavaScript library to drive the headless Chromium, the Chrome browser. So how you use Selenium, like you spawn up a browser out there, the same way Puppeteer is spawning up a browser, and then we are imitating the behavior of an actual user, like provide the credentials, log in, click here, go to the next page, go and perform some operations. And that's how we are doing. So we are using Puppeteer. There is a new library in the market called Playwright that is released by Microsoft. Puppeteer was released by Google as an open source. Playwright is also open source. And the fun fact is that the folks who created Puppeteer, they just moved from Google to Microsoft, and they have created Playwright. Why do we need two of them? As I told you, Puppeteer is just for driving Chrome. You cannot drive Firefox, whatever. What if you have to do cross-browser testing? You cannot use Puppeteer. But however, Playwright, though it is not very standardized, it allows you to test on IE. Right now it is Edge, Chromium, Safari, and Firefox. So it's like a higher version, advanced version of Puppeteer. And maybe I'll take a moment to also answer Sri's question out here. Sri, like we saw Playwright, I thought, okay, this is the best thing which we could use. But does that mean I have used it in my system? No, I was just starting developing this end-to-end test cases. but I still use Puppeteer because that system was well supported in my ecosystem, in my infrastructure, in my foundation of my company. So I still did not use the latest shiny thing, but I used whatever is stable and what is familiar with most of my teammates.
Thank you.
So Deepa, again, to answer your question, right now we are using Puppeteer, but we have been using Selenium for a long time because most of the time those tests were not written by UI engineers. But since UI engineers are writing tests today and they are very, very familiar with JavaScript, and once Jeff Atwood, the founder of Stack Overflow, he famously quoted, anything that could be written in JavaScript will be written in JavaScript. So we prefer to do it in JavaScript, and that gives us the most productivity.
That's very awesome, Sarbotam. Thank you for sharing that. I've just put in the link where you can just click on it and get the basics of Puppeteer. It'll take you to the Google developers page. Folks, keep asking your questions. I know some of you are from neither front end nor back end, more like project program management or QA or systems analyst kind of a background. Even then, please do ask your questions.
Hi, Sarbotam. This is Sheetal.
Hi, Sheetal.
Hi. Thanks a lot for all the knowledge that you're sharing today. Just a little about myself. I have been a DBA for a long time of my career, and I have very little knowledge about the front-end application. Apart from the HTML, CSS knowledge that we learned in college days, I had absolutely no idea on what's going on there in the front end. And today it was really helpful that you shared so much. So system design part during the technical interview, as we know that all of us, irrespective of our technologies, we tend to face this, interview round of system design. And whatever information that you shared, having a dialogue with your interviewer, like a colleague, that was really helpful. Do you know of any books or any online resources that can help us more on this?
Oh, definitely. I think Subha, I'm not sure if you're there yesterday, Subha covered it a lot. Like there is a site called educative.io, which I think Shubha mentioned it yesterday. And there are tons of, there are many organizations who are actually doing this, like they're giving this interview coaching and all. But I'll probably start with educative.io. I tried it once. It was really nice. Like they have this content very well placed. And one thing which I kind of realized, like, it gets very frightening. Like, okay, even I feel the nervousness, like, okay, I was feeling nervous even before this presentation. But I think once you start doing it, once you start loving it, once you start, suppose a question has been asked to you and you just get into that question, just think it is you're not giving an interview. It's your actual technical project, how you want to solve it. The moment you think it in that way, doesn't matter whether you solve it completely or not. If it is a new challenge, nobody can solve it in 45 minutes. Trust me. Like if you have not seen a problem and I give you that problem for the very first time, it's very, very difficult. Only few people can solve it. Like, but if you have solved those problems over and over and over and over and again, you probably will recognize a pattern. So again, I'll quote Subha, which he said yesterday, there is no shortcut. You have to practice it, and the situation is really competitive. So you have to practice it, but educative.io for system design is a really, really good resource. It's very good for system design.
Thank you. That helps.
So
Sure.
Sarbotam, thank you. And Sheetal, this is Subha. If you did attend our first session on Tuesday, and I shared the deck with everybody who attended our call. So I hope you have a copy of the presentation. And towards the end, there are a few slides that talk about resources. Educative.io, as Sarbotam mentioned, definitely But Educative does have some content through subscription only, although it's very, very nominal, but not everything is free. If you go to YouTube, there are a few videos by Gaurav Sen, and one of the links I've just pasted there. That could be a great starting point. It's very, very fundamental, and most of his videos run, between 20 to 30 minutes long, and it's very basic. It's like a high school level kind of a thing. But that alone will give you an idea, right? So, say for example, if somebody is asking you to design an application like Uber or an application like LinkedIn, where do you even start? Right? There is no way you can solve these problems right there when the interviewer asks you. You should have done several of these, and you should really know, how are you going to break the problem down? What are the different layers? How, the kind of data access that you're going to use, data store you're going to use, whether you're going to leverage the cloud and so on and so forth. So, and as you think through this, and as you explain your answer, and Sarbotham gave a very good framework today, right, in terms of where do you start? You start off by asking questions. I covered the same thing on Tuesday. You don't start designing right away. But even then, once you're done with it, the interviewer will ask you, hey, now I need to scale this. Now I need load balancers. I need this. I need that. How will you go about doing it? So unless you have put in, if you have the background, and if you've put in a lot of effort through your programming years in doing some of these things, it's very difficult to have a convincing answer, right? So there is no shortcut to that part. But in our future sessions, we will be covering a lot of this content, including potentially system design as well. So please do keep joining us. We'll be meeting twice a week. So this week we have had both our sessions. And both sessions were really very helpful to all the attendees. And we will be meeting again on Tuesday. So for Tuesday, the agenda as well as what we are going to cover, all that stuff, I will be sharing it with you via email. We have not finalized that yet, but we will get back to you on that. Yeah. So please do continue joining. I just wanted to hear from you folks. Are you finding these sessions helpful?
Yes, Suva. Thanks a lot for answering my questions.
Okay, good. Fantastic, Shri, and thank you for your feedback as well, and Deepa too. And we're seeing a lot of chat messages. Thank you. And so it's 6 o'clock. I had promised to Sarbotham that we will not go beyond 6 o'clock. So I have to stop here. If you have any further questions, please email them to me, and I'll get them forwarded to Sarbotham. Sarbotham, thank you once again for spending time with us. You even spent time with us on Tuesday. So thank you once again, and from all of us, a big round of applause.
Thank you, everyone. And I will be replying back to the email from Subha with that PDF version of the presentation. It might be helpful for you all to just look back and what we have talked about. And once again, thank you, everyone. It was really nice talking to you all and for your time. Thank you.
Wonderful, Sarbotham. Thank you, and thank you all for joining. This concludes our BayOne Tech Bootcamp for June the 4th. The next session is the upcoming Tuesday at 4 o'clock again, and that will be June the 9th. See you then. All details will be shared with you via email. Thank you so much. Bye-bye and good night.
Bye-bye.